Is the ovary model, and it's an easy model, but it's a model a lot of people get confused by, and I think it's because it tries to do too much at the same time. Like what they're attempting to do with this model, they show you all your stages of follicle development almost like they happen concurrently, and that's not the case. They follow each other in a sequence, and they just put them all in here at the same time so that they don't have to make like 10 models and lay them out in a sequence. This is the ovary. This is the ovarian ligament that's going to run between the ovary and the uterus. This is part of the broad ligament called mesovarium. I would not ask you that on the lab exam because the mesovarium is not on there this year. But basically, if it's not ovarian ligament or suspensory ligament or round ligament, any of the other mesenteries that support uterus, fallopian tube, ovary, they're all going to be the broad ligament. Okay. As for the ovary model itself, the epithelium on the outside is properly called the germinal epithelium. I think it's referred to as visceral peritoneum in the manual. I don't quite buy that. I call it germinal epithelium. If I dissect that off, there's a connective tissue shell underneath there. Very tough. It's like where all those white fibers are. That's the tunica albuginea. So the connective tissue wall of the testis is tunica albuginea. The connective tissue wall of the ovary is also tunica albuginea. And then we're down to just the two major regions within the ovary. The outer region that has all the follicles in various stages, that's called the cortex. And then the deeper part where the blood vessels are is the medulla. Easy, okay? Then here's where we start to get a little bit sort of crazy with this model. See all the little yellow sort of splashes? Those are primary follicles. And in a typical ovary, there's about 200,000 of those out in the cortex. So I think it's misleading. They only show a few here and a few over here. You have 200,000 of those total. Okay. Then in each reproductive cycle, at the beginning of the cycle under the influence of FSH, maybe a dozen follicles will start to respond to it. They're going to grow. They're going to secrete estrogens into the blood, just like I showed you with the overhead. And then of the 10 or 12 that were excited by FSH, one's going to go the full distance, and it's going to become a mature follicle. So this is like the primary stage. Here we have the mature follicle. Mature follicles are oftentimes called Graafian follicles. So it's kind of up to you if you want to use that term or not, but Graafian, Graaf, I guess, was the person that discovered them anatomically. But this is a mature Graafian follicle. And the thing is, it's ovulating. So the ovum here is actually in the process of being expelled from the surface of the ovary. If you would have caught this just a little bit before ovulation, this would have been in a compartment at the back of the follicle. So until ovulation, the ovum is in this little compartment at the back of the follicle's full of fluid, and then under the cue of LH from the anterior pituitary, this pops open, the fluid is expelled, and the ovum is expelled too. So this one's caught in the process of ovulation. What do we have in between primary follicle and this? Well, you're going to have a secondary stage, and the secondary stage is right here. And then you have an enlarged version of the secondary stage. And I think in Dr. Sinclair's manual, she calls it growing follicle. Okay? So we go from primary to secondary to further growing follicle. Here's the mature follicle in the process of ovulation. This here is a follicle that is starting to fall by the wayside. This one that doesn't, like it began to respond to the FSH, but now it's deteriorating. And they actually call those atretic follicles. I'm not going to ask you that, okay? But I can tell that this is atretic because there's no nucleus. It's just starting to disintegrate, okay? So then what happens after ovulation? Well, the ovum's expelled, the empty follicle fills with blood, and it becomes the structure right here. And this is going to be easy for you to remember. It's called corpus hemorrhagicum. Hemorrhage means bleed. That blood that's in there, that's going to make it easy for you to remember this is corpus hemorrhagicum. So we go from here to here, immediately to here, and then the corpus hemorrhagicum seals up, the blood is absorbed, and this then becomes the corpus luteum, which is over here. See how this thing sort of pops around from one place to another? Don't be confused by that. Everything's going to happen in the same region, but they just spread them out so they could show everything on one model. I'll do the complete sequence over for you when I'm done. Okay. So the corpus luteum, powerful endocrine gland, secretes estrogen, a lot of progestins, estrogens into the blood. If it's not a fertile cycle, this dies on about the 24th day, and it becomes a piece of scar tissue called corpus albicans. Now, at first, that scar tissue is pretty big, but then it eventually gets smaller. So they show that as corpus albicans. They show that as corpus albicans too. Okay, so to do the whole sequence of follicle stages for you real quickly: primary follicles, secondary, growing. This one's fallen by the wayside. Okay, this is a mature follicle in the process of ovulation. After the ovulation has occurred, this fills with blood and it becomes a corpus hemorrhagicum. That almost immediately seals up and becomes the endocrine gland we call the corpus luteum. And if it's a non-fertile cycle, that dies on day 24 and it becomes corpus albicans. And yeah, the corpus albicans is permanent scar tissue. It's going to stay there forever. It's going to get smaller, but it's going to stay there. So that's your ovary model.